Okay, so welcome everyone to the fifth lecture of quadratic equations and expression. So I hope you all are doing great and I hope you are following the lectures. In case any doubts are there, do let me know through chat. In case any points to be retaught or in case you want me to make some concepts very much clear or if you're not very thorough with any particular question, do let me know. I'll try my best that I get it covered in the very next lecture. Okay. So last class we have solved some couple of questions and I gave you a couple of questions as homework. I hope this tag of J means question would have excited you to solve this question. So in case you have got the answer, please do let me know through the comment so that I will also have an idea that okay, you are following the lectures properly and you are getting the right answers. Okay. So coming back to this question, what they are saying that one root is cube of the other. So this directly fits into the template of the types of question that we have discussed, that one root is twice the other, one root is five times the other, one root is square of other, one root is nth times of other. For all these problems, we have a very similar kind of approach. So what is the approach? Let the roots be alpha and alpha cube. So then we can go with some of the roots. So alpha plus alpha cube will give you minus b by e, and product of the roots alpha into alpha cube will give you alpha to the power 4, which is equals 256 by 81. I hope 256 by 81 you have been able to visualize as 4 by 3 to the power 4. So this we can write as 4 by 3 to the power 4. So what is alpha? So one root could be 4 by 3, other root could be minus 4 by 3. And since the degree is 4, how many roots should be there? 4 roots should be there, isn't it? So there will be two other roots, but since it is a single correct, I am just hoping and I am trying my luck that out of this 4 by 3 and minus 4 by 3 may give me one of the correct options. And since it is single correct, definitely more than one options are not correct. So in case my luck's favor, I will go ahead with that. In case it's not, then we have to look into the other two roots which we have not been able to figure out so far. Okay. So let's go with case one. Case one, alpha equals 4 by 3. So what you got? You got 4 by 3 plus 4 cube by 3 cube equals minus k by 81. Okay, I can see there is 81 on the right side and here left hand side you can see the denominator is 3 and 27. I'm getting tempted that okay, let's take LCM, not LCM, let's directly multiply 3 into 27 so that I can later on cancel this 81. Or the other approach is bring this 81 on left hand side and cancel and then you proceed with this. Okay. So as you wish, you can proceed. This is a very simple calculation you can do. Your siblings can also do. I mean the younger ones. So when you calculate this, here you'll be getting something like 81 and here we'll be getting 27 into 4 is 108 if I'm not wrong. Yeah, and 64 into 3 will give you 192, which is equals minus k by 18. So when you do the calculation from here, you got k equals minus 300. And I can not trust my luck that in the very first attempt, I can see that your option is matching perfectly. So the answer for this question is going to be minus 300. So the right answer for this question is minus 300. In case it is a multi-correct, then definitely we should see that with minus 4 by 3 what value we have been able to get. And the other two rows which I have not you know given as attempt to figure out, we try to figure them out, or if not some relations, and through there we try to evaluate the k value. But in this case it was a simple one, easily we have got it. So let us move to the second question. The second question is if lambda is the ratio of the rows of the quadratic equations, some equation is given and then they're asking the least value of for which this lambda plus 1 by lambda equals 1. Now the first information that we can generate from here is that the moment they have mentioned that it is a quadratic equation, it means the coefficient of x square cannot be 0. So what is the first information that I can list down here is m is definitely not going to be equal to 0, right? Now the second part is what is lambda? So lambda is the ratio of the roots. Which roots? So we have to introduce, isn't it? So let us introduce that let alpha and beta be the roots of the given quadratic equation. Okay, QE, given quadratic equations. So what they are asking, lambda plus 1 by lambda. So I can go step by step. So what is lambda? Lambda is alpha plus beta. What is 1 by lambda? Which is beta by alpha. And according to question, they are telling, according to question, lambda plus 1 by lambda equals 1. So in short, what are we getting? Alpha by beta plus beta by alpha equals 1. So when you simplify this, you got something like alpha square plus beta square by alpha beta equals 1. And from this, what will we get? This we can write as alpha square plus beta square equals alpha beta, right? And this we have discussed already in the very second lecture, that alpha square plus beta square can be written as what? Alpha plus beta whole square minus 2 alpha beta equals alpha beta. So ultimately what we got alpha plus beta whole square equals 3 times alpha beta. So this is the equation we have got, and this is the equation which is going to help us in finding the value of m. So now the question comes, what is alpha plus beta? So let us list them. Alpha plus beta is minus b by a, which is minus m times m minus 4 by 3m square. The very first thing in this question I mentioned is that m is not equal to 0. So ultimately what we got, minus m minus 4 divided by 3. And what is alpha beta? C by a, which is 2 by 3m square. 2 by 3m square. So take these values and feed it. So when you feed, what you'll be getting? Alpha plus beta is whole square. So negative square will give you, and minus is there, isn't it? So when you square it, that minus will be taken care. So ultimately we will get like m minus 4 whole square divided by 9m square equals 3 into alpha beta, which is 2 by 3 m square. So 3 and 3 will get cancelled, m square will get cancelled. Reason, m is a non-zero quantity. I have been reminding it again and again. Try to see, simply don't cancel it. Like you should have a valid reason to cancel it. Since I'm mentioning here that m is not equal to 0, in that situation we can cancel. Else you may lose the roots. Now when you send on the right side, we got something like m minus 4 whole square equals 18, isn't it? So m minus 4 we can get how much? Plus or minus 3 root 2. And what is m? M is 4 plus 3 root 2 or 4 minus 3 root 2. So they are asking, what is the least value? And here only one option is there, so you don't have any confusion. You can directly mark 4 minus 3. I mean, what point I wanted to make here is that they are asking the least value for which this equation holds true, which is lambda plus 1 by lambda equals 1. So m value is going to be 4 minus 3 root. And we can neglect the other value, right? So I hope you are comfortable on this. So let us see some more couple of questions. Okay. So now the question which we are going to see is a very beautiful problem. Okay. So the question goes something like this. Question is, let alpha comma beta be the roots of quadratic equation x square plus px plus 1 equals 0, and gamma comma delta be the roots of quadratic equation x square plus qx plus 1 equals 0. Then prove that p square minus q square equals alpha minus gamma, beta minus gamma, alpha plus delta, beta plus delta. Okay. So question is what? Question is that alpha beta are the roots of x square plus px plus 1 and equals 0, and gamma and delta are the roots of x square plus qx plus 1 equals 0, and then we have to prove that u square minus q square equals alpha minus gamma, beta minus gamma, alpha plus delta, and beta plus delta. Okay, so how shall we proceed with this question? Think, how shall we proceed with this question? So one thought that normally students given the class is, so right side we can multiply. So you will get something like alpha square. I mean multiply all of them. You may get something like alpha square multiplied with some terms beta square, and then you simplify and use the fact that alpha plus beta equals minus b by a and alpha into beta equals c by a. So they give an idea like that. Okay. Or some students give another idea that do one thing. You know that what is p square. So p square is alpha plus beta. Yes. So then they will say like, okay, do one thing. In place of p, you write alpha plus beta whole square. I'm like, okay, that's fine. Okay. And then q square. So that will give you what? I mean, what basically this is. In place of p, what we can write? Alpha plus beta square. And place of q, what we can write? Gamma plus delta square. And then you can see like this a square minus b square is there, so you can write something like alpha plus beta plus gamma plus delta multiplied by alpha plus beta minus gamma minus delta. And then after I ask what is next, then there will be mostly a silence in the class. Okay. So this is not working out, right? Then some people will say, okay, no problem, you do simplify this and prove that this is equal to this. So I do appreciate them for the courage they have, because they will go and multiply this and then all the simplification they will be doing. So these are not the ideal ways of solving this question. So in case if you want more time to think, pause the video, think about it, and then come back and see the check the solution. Okay. In case you're getting the answer, definitely let me know, because you definitely deserve appreciation, because this question is not a, it's a beautiful question basically. Okay. Now coming back to this, if you try to recall the second or the third lectures, there I have asked you to solve a question like, x square plus 5x plus 3 is a given equation, and find me what is the value of something like 5 minus alpha into 5 minus beta. And then I have asked you what is 3 plus basically 25 square minus alpha square and 25 square minus beta square. If you try to recall that question, find the value of 25 square minus alpha square and 25 square minus beta square. And then we calculated, isn't it, using the fact that ax square plus bx plus c can be identically written as a times x minus alpha into x minus beta, right? So that is the logic that we are going to use here to solve this question. Okay, and if you don't use that, trust me, you'll be it will be little complicated to get the answer by some other means. In case you have some any easier approach and you have been able to figure it out, I would be happy that do let me know. Okay. So coming back to this question, my first part is, if I see this equation, isn't it? So this x square plus px plus 1 can be identically written as x minus alpha, x minus beta, right? And in a similar way, x square plus qx plus 1 can be identically written as, x minus gamma, x minus delta. Okay. Now, when you try to observe this expression, can you see like I would have been happy if alpha come this side, beta come this side, then something I'll be able to relate. So I can help you out with that. This can also be written as alpha minus x into beta minus x. Any trouble with it? Absolutely no. Reason is simple, that we took a minus from the first bracket, we took a minus from the second bracket, and they have got compensated on their own. Okay. So we can write like this. Now I'm saying see these two ways. And what thought is emerging? That if we can replace x equals gamma, we will be able to generate this, isn't it? So let's do it. So what we are doing, we are substituting x equals gamma. So what you got? Gamma square plus p gamma plus 1 equals alpha minus gamma and beta minus gamma. In a similar fashion, when you try to concentrate on the other two guys, these two guys, now what value of x shall we substitute so that we can generate alpha plus delta and beta plus delta? Think. You can see like if we substitute x equals minus delta, isn't it? Because you want to make it positive. Okay, try to recall with that 25 minus alpha square, 25 minus beta square. We have done already this part. Okay. So if we replace x equals delta minus delta, what we will get? Delta square minus p delta plus 1 equals alpha plus delta and beta plus delta. Sometimes students, what when I ask again in the class, those who are sleeping or those who are not very much attentive, whether I should substitute x equals minus delta in the first equation or in the second equation. So they think that okay, first equation anyway is used, it is already there on the board. So definitely it must be the second equation. But you should understand we are not substituting in the second equation, it is the first equation only. Okay. So let's take it out. Okay. Now you can see like you have generated alpha minus gamma, beta minus gamma, alpha plus delta and beta plus delta. So what is the next part? The next part is that you have to just multiply them. So when you multiply these equations, what you'll be getting? You got something like gamma square plus 1 plus p gamma multiplied by delta square plus 1 minus p delta equals the required question, which is alpha minus gamma, beta minus gamma, alpha plus delta and beta plus delta. Okay. Now, how shall we proceed? So again, don't do the hard work. Try to be smart. I am not going not to multiply this because again, if I have to multiply, I could have multiplied at the starting itself, isn't it? So how shall we proceed? So again, try to see by any means can we generate the value of a gamma square plus 1? So we know that gamma and delta are the roots of x square, x square plus qx plus 1 equals 0. You can see like from here you can write gamma square plus 1 equals how much? Minus q gamma, and delta square plus q is equal to how much? Minus q delta equals minus q delta, right? So next what we will do? We can feed those values here, isn't it? So this guy will become gamma square plus 1 equals minus q gamma plus p gamma, and this will be minus q delta minus p delta. Observe this. You can see like if you take gamma outside, you got here p minus q, and here you take delta outside or minus delta outside. So what you got is p plus q. So when you multiply this, you got something like p square minus q square negative of gamma delta. What is gamma into delta? Gamma into delta equals 1. Feed that value here again. So ultimately what we got? We got q square minus p square. We got how much? Q square minus p square. So that is the required proof. I hope again we're clear on this. So my idea or request would be is that try to solve as many problems as possible from whatever the sources you are having related to the basic concepts. Okay. And now we'll be moving to the next concept, which is the transformation of roots. Like alpha and beta are the roots of a given equation. So we are going to do some transformation and generate quadratic equation whose roots are, let's say, alpha plus 3, beta plus 3. So normally you know the method. What I mean is, let's say alpha and beta are the roots of a quadratic. Then find me a quadratic equation whose roots are alpha plus 3 and beta plus 3. You can find some of the roots and product to the roots and you can proceed. But what if in case I give something like alpha plus 3 by alpha plus 1 and beta plus 3 by beta plus 1. So you can see like, the complications will come, isn't it? All these type of problems we can handle very easily. That we'll be discussing in the next lecture. Okay. So in meanwhile, try to see all these problems. Let us see you guys in the next lecture. And that's all for today. Thank you so much. Take care. Bye.